Hi students, now coming to the next topic, that is the quick sort. So this is one of the example of the divide and conquer. In the previous video I explained about the merge sort. Now let us see what is this quick sort. Actually this quick sort is an efficient algorithm. So when compared to the rest of the algorithms like merge sort, binary search, this quick sort is an efficient algorithm. Mostly in the languages we will use this quick sort method. Efficient sorting algorithm, and it is an example of divide and conquer algorithm. This is an example of divide and conquer algorithm. Okay, so what is the main idea of using this quick sort? Why we are using the quick sort? The main idea behind this quick sort is here the algorithm is partition the given element, whatever the given element is there, into two sets. So partition, first you have to partition the array into two sets. Okay, so one set and another set. So you have to partition the array into two sets, one set and another. In one set, smaller numbers will store. Smaller numbers will place in one set, and in another set, larger number should be placed. So how can I divide the smaller elements and the larger elements? So I am saying that the partition the array into two sets. I have to partition the array into two sets. So with the one, I have to make all the smaller elements in one side and all the larger elements in another side. Okay, so how can I do this? So this partition, whatever I am doing in this quick sort, this partition is done with respective an element. So with the help of one element, I am going to do the partition. So the partition is done with respect to an element that you call it as a pivot element. You have to call that element as a pivot element. So based on one element, so the pivot element is any element that is present in an array. So array consisting of a group of elements. So in that you can take the first element, middle element, last element, second element, third element, any element. Okay, so the partition is based on that element. We just sorting the array based on the selected element. So that selected element you call it as a pivot. So the partition is done with respect to an element called a pivot. Okay, so after selecting the pivot element, you have to repeat the process for both the set until each partition contains only one element. So you have to repeat the partition process. You have to repeat the process for both sets. Both sets means the smaller one and the larger one, for both sets until each partition contains only one element. So until it reaches the one element, you have to repeat the process. So I'll explain with an example. So what is this? How can I make one element as a pivot element, and how can I make the all elements as a how can I select the smaller numbers and the larger numbers, and how can I repeat the process for all the sets until it reaches one element? So let's see this with an algorithm. First I'll explain and I'll give the algorithm of this. After that, example. Algorithm. So okay, let me take first partition. Actually I said two phases will be there. Let me tell that before going to algorithm. A quick sort, whatever the quick sort we are doing, a quick sort can be done in two phases. So with two phases we can done the quick sort. So one is a partition phase and another there is a sort phase. So first you have to do the partition. So after doing the partition, then you can sort the array. So the quick sort can be done in two phases. So in the partition phase, what we will do, we will just divide the work into two halves. So how can I divide the work into two halves? That I will discuss in the partition phase. And the sort phase, coming to the sort phase. So what is the sort phase? You have to conquer the half, means you have to solve the problem like sort the array, and you have to combine the partitioned halves into single the original form. So this is a two phase. A quick sort can be done in partition phase and the sort phase. Okay, so let me take the first the partition phase. So before going to the example and algorithm, let me give a basic idea about the partition phase. So in the partition phase, we have to first choose a pivot element. First you have to select a pivot element, whatever the array consisting of a group of element, in that you have to select a pivot element. So after that, you have to find the position of the pivot element. Find the position for the pivot. So first choose a pivot element. After that, you have to find the position for that pivot element, so that all elements of left or less or equal and all elements of right or equal or greater. So this condition you have to be noted. So whatever the element that you are selecting, that is a pivot element, that pivot element has to place in one position. So while you are placing that pivot element in that position, you have to be take care that the elements that are present left side of the pivot element is less than or equal to pivot, means all small less elements or smaller elements, lesser elements than pivot. Okay, and here it should be equal to greater than pivot, means greater than pivot. So this thing you have to be noted. So whatever the you're just partitioning, you're not sorting the elements, you're just doing the partition. So this is the first phase. In the first phase, you will just do the partition. After that, you will perform the sorting technique. So don't be confused. In the partition phase, phase, you are just selecting the pivot element. That pivot element is present anywhere in the array, your first, last, middle, whatever. So just select that element and place that pivot in one position. How can I place the pivot in a position? Find the position for the pivot. So that should be, you have to follow all the elements. Left side the pivot element or should be less, and right side it should be greater. Okay, that thing you have to be noted. And coming to the next is the sort phase. So after doing the partition, you have to sort the element. How can I sort the elements? Okay, so sorting the elements can be done by applying the same algorithm to each half of the pivot. Just apply the same algorithm to each half of pivot. So how can I apply like this? So just if you take the pivot element, so this is the pivot element that is present in the middle. So right side of the pivot element should be greater than the pivot, and the left side should be less than the pivot. This thing you have to be noted. So here again you partition the pivot element. So this is a P1, left side is equal to P1 and is equal to greater than P1. And here is also less than or equal to P2, and P2 is the pivot element and is equal to greater than P2. Means again, whatever the elements here, that again you are doing the partition. Selecting the pivot element, again doing partition. Selecting the pivot element, again you are sorting. Like that, you have to sort the array. So this is how the quick sort is divided into two phases, partition phase and the sort phase. So in the next video, I'll explain about the algorithms related to this partition and sort phases and the examples for this partition and the sorting. Thank you.